In 2025, Google spent more money on AI infrastructure than the entire annual GDP of a small European nation, roughly $75 billion in capital expenditure, much of it on data centers and custom chips. And yet, inside the company, something strange is happening. Engineers who built the systems that power half the world's information flow are quietly updating their resumes. Not because the company is failing, because they're watching a different clock, one that Google didn't start, can't fully control, and may not be able to outrun. The threat people talk about is OpenAI. ChatGPT, GPT-4, the Microsoft partnership. That narrative is real, but it's also already priced in. Google adapted. They launched Gemini, rebuilt search with AI overviews, and held their market share. What they haven't fully adapted to is something quieter and far more structurally dangerous, a shift in how AI is being built, trained, and deployed that could make Google's entire architectural advantage obsolete. Not in a decade, in roughly 3 to 5 years. Here's why this matters to you right now. Google's core business, the one that generates more than 77% of its revenue, is search advertising. Every time you type a query and click a result, a tiny financial transaction occurs. In 2024, that system generated over $175 billion. It is one of the most profitable businesses ever constructed. But that machine has a single critical assumption baked into it, that you will keep asking questions the way humans have always asked questions. Type a phrase, get a list, click a link. What's emerging now doesn't work that way at all. AI agents, systems that don't just answer questions but complete tasks autonomously across the internet, don't click ads. They don't browse. They retrieve, synthesize, and act. If your doctor sends an AI agent to research your medication options and book your appointment, Google earns nothing. That's not a hypothetical. That's already happening in early enterprise deployments across healthcare, legal, and financial services. The second implication is structural. Google built its moat through data scale. More searches mean better results, which attract more searches, a flywheel running since 1998. The new architecture threatening them breaks that flywheel entirely. To understand what's actually coming, you need to know how we got here. For most of AI's modern history, roughly 2012 through 2022, progress was driven by one formula: more data, more compute, bigger models. Google was extraordinarily well positioned for this. They had more user data than almost any organization on Earth, vast computing infrastructure, and some of the world's best researchers. They literally invented the transformer architecture in 2017, the foundational technology that powers every large language model today, including the ones being used to compete against them. That paper, "Attention is All You Need," was written by Google Brain researchers. They handed the world the blueprint. And for a while, that was fine, because building on the blueprint still required resources only a few organizations could marshal. Think of it like inventing the internal combustion engine and also owning every oil refinery. You feel safe. Then someone figures out a completely different kind of fuel. That different fuel has a name: test time compute, sometimes called inference time scaling. Here's what it means and why it changes everything. Traditional AI models are trained once, expensively, and then deployed. The intelligence is essentially frozen into the model's weights, like printing an encyclopedia. What researchers discovered in 2024 and 2025 is that you can make a model dramatically smarter not by retraining it, but by giving it more time and computational resources to think during the actual conversation. OpenAI's o1 and o3 models demonstrated this clearly. Instead of answering immediately, the model reasons through a problem step by step, checks its own work, backtracks, and tries again, all in real time. The result was stunning. On the ArcAGI benchmark, a test specifically designed to resist pattern memorization and require genuine reasoning, GPT-4 scored around 5%. OpenAI's o3, using extended compute at inference time, scored 88%. That's not an incremental improvement. That's a phase transition. And here's the part that should make Google's board uncomfortable. This approach means a smaller model, given more time to think, can outperform a larger model that answers instantly. Google's advantage was always scale. This partially decouples intelligence from scale. The implication runs even deeper when you look at what it means for model architecture. Google's Gemini models are extraordinarily powerful, but they are optimized for a paradigm that is quietly being replaced. The new paradigm isn't just about thinking longer, it's about agents. Systems that can use tools, browse the web, write and run code, send emails, manage files, and loop back on their own outputs. Anthropic's Claude has been deployed in agentic pipelines at Fortune 500 companies since early 2025. OpenAI's operator product allows AI to control a browser directly. A startup called Cognition built Devon, an AI software engineer that doesn't just suggest code. It opens repositories, writes tests, debugs failures, and submits pull requests autonomously. In a survey of 200 senior developers published in early 2026, 34% said they now use an AI agent for tasks they previously delegated to junior engineers. The market for AI agents is projected to reach $47 billion by 2028, growing at nearly 45% annually. What's significant isn't just the number, it's the direction. Every task an AI agent completes is a task that never passed through a Google search. The bypass isn't theoretical. It's already operating at scale. The mechanism making all of this possible is worth understanding directly because it's more counterintuitive than it sounds. When an AI agent operates, it doesn't just run one model once. It runs a loop. The agent receives a task, breaks it into subtasks, uses tools to gather information or execute actions, evaluates the output, and decides whether to continue or revise. This is called a reasoning loop or an agentic loop, and it's fundamentally different from a chatbot answering a question. Think of the difference between asking a librarian a question and hiring a research assistant for a week. The librarian gives you their best immediate answer. The research assistant works the problem over time, checks sources, hits dead ends, and comes back with something more reliable. What makes agentic AI counterintuitive is that the intelligence isn't in any single step. It emerges from the iteration. A model that seems mediocre in a single-shot conversation can produce remarkable results when embedded in a well-designed agentic loop. This is why smaller, faster, cheaper models from companies like Mistral or Meta's Llama series are suddenly competitive in production deployments that previously required frontier models. The loop architecture redistributes power away from whoever has the biggest model and toward whoever designs the best system. The complications here are real and shouldn't be glossed over. Agentic AI systems can fail in ways that are difficult to predict and harder to reverse. In early 2026, a financial services firm using an autonomous AI agent for contract review discovered the system had been quietly approving modified terms for 6 weeks before a human auditor caught it. The model wasn't hallucinating randomly. It was confidently wrong in a consistent direction. That's more dangerous than obvious errors. The second problem is that inference time compute is expensive. Running extended reasoning on a complex task can cost hundreds of times more per query than a standard model response. This creates a real ceiling on democratization. The companies best positioned to absorb that cost at scale are the hyperscalers, which ironically means Google Cloud still has a role. But Google, the search business, and Google Cloud are two different economic engines. One may thrive while the other erodes. A third complication is privacy. Apple is currently debating whether its upcoming smart glasses can record video, according to Bloomberg, and that debate reflects a broader cultural resistance to always-on AI systems that could supercharge agent capabilities but require constant data access. For you personally, the shift is already arriving in specific sectors. If you work in software development, legal research, financial analysis, customer support, or content moderation, AI agents are not a future threat. They are a current productivity tool your competitors are deploying right now. The specific thing to watch is not whether your job disappears, but whether the junior roles that used to feed your pipeline disappear first. The entry-level software job, the paralegal position, the junior analyst, these are being replaced by agentic loops that cost a fraction of a salary. That means fewer trained humans moving up the ladder into senior roles over the next decade. If you manage a team or run a business, the actionable question isn't whether to use AI. It's which tasks in your workflow are currently running as single-shot queries that should be redesigned as agent loops. That reframe alone is worth significant efficiency gains in the next 12 to 18 months. Google is not dying. Let's be precise about that. They have 180